So we're here with Dr. Sturrus, one of the senior educators and professors at YSU. Obviously, if we have a physics educator in the building, then you automatically assume that we must be doing some physics experiments. So we're going to focus on some physics activities and demonstrations. Dr. Sturrus is here, and he's going to be able to sort of walk us through some things that you can do with a lot of really familiar materials that you would find in your own home. Again, the mission statement that OWOW is always stressing is find what you've got, right? Use less to produce more. So if we can help you generate some ideas with some nails and some 2x4s, a little bit of, water, then so be it. And that may parlay into some more wonderful, fantastic experiments. And hopefully you as a community purchases one of those STEM bundles and gets 4 of these wonderful physics, science demonstrations so that you and your family can enjoy hours and hours of engagement and say, oh wow.
Oh wow, yes, of course.
Yeah.
All right, so one of the cool things you can do is a lot of different experiments that have to do with buoyancy or floating objects. Okay, so the person who sort of quantified this in a physics sense was named Archimedes. He was even older than me, I think, when he thought of this. So what we're going to do is start out with a couple of things. One of the important things about floating is water has a certain density. If I put something in water that's less dense, okay, mass per unit volume, I can get it to float on the water. So you can imagine pouring some salad oil on the top of this and it'll make a layer on the top because it's less dense. But we're going to try different objects you can see easily. This is a packet of ketchup, nice red packet so you can see it. I picked, by the way, if you're trying to do this at home, I picked one of these real crinkly glass drink bottles because it's easy for even children to squeeze it pretty well. It doesn't have rigid sides. Now the problem with it is it's not as clear. Ralph over here has some really nice ones that you'll be able to see better, but you'll be able to see this, I think, inside. So if I put the ketchup packet inside the bottle, you can see, probably can see, that it's floating.
I have mustard, just so you know. I'm more of a mustard guy, and obviously Dr. Sturrus here is more of a ketchup guy.
Yeah, well, I'm just trying to catch up with Ralph if he's the mustard guy. So what I'm going to do now, you see it floats. I put the cap on the bottle because now what I can do is I can squeeze the bottle. I'll try to do it so you can see the contents inside. And I don't know if you can tell, but the ketchup packet has sunk to the bottom as I squeeze it. If I let go, it'll come back up. Now what's happening is the ketchup packet has a little air bubble in it, and if I squeeze it, the air bubble is compressed. See, you have to have muscles to do this. Yeah, the air bubble is compressed so that the density of the packet increases beyond the density of water it sinks.
All right,
Now he's got a nice clear bottle so you can see what's not happening in his bottle, and what is happening in mine is it sinks. Maybe it's a weight thing. He's got to go lift weights and work out. Or maybe it's something else. It might be that this is so much less dense than water that he can't even squeeze the air bubble in the packet enough to get it to sink. Why don't you try to make this packet more dense? How could you do that?
Well, so if we have a bunch of children around us, obviously if you want to make things more dense, we would probably need to add some weight, right? Okay, so if you're out there and you're looking at us and going, add weight, add weight. So it's a really challenging situation. How would I add weight to the packet of mustard here? Well, again, utilizing things that you would have in your own home. So I'm gonna take the packet out, right? What if we used just one of your regular old paper clips, right? And you just paper clip on there on that little mustard packet, right? You put the packet back into the bottle. You fill it with water. Now again, if you have an Uncle Ephus out there who's always trying to bet you that you can't do something, and you want to take his money, because Uncle Ephus always has a pocket full of hundreds, you can say, okay, Uncle Ephus, give him the packet of mustard that doesn't have the weight on it, and see if he can get his to sink. Slyly slip your paper clip on your mustard packet and say, Uncle Ephus, I bet you $100 you can't get your Cartesian diver to dive. And when he tries to squeeze his packet that doesn't have a paper clip on it, and spends 37 seconds, you can just go, Uncle Ephus, I added weight to mine. And there it sinks. And a quick, cool $100 for you, so you can go buy Uncle Ephus some Jib Jab hot dogs or head up to YSU to wonderful Chick-fil-A, right?
Why don't you put another paper clip? It's stuck in the middle now.
Yeah.
Put another paper clip on it and see if it's even easier to get it to sink.
We can do that, sure.
Yeah, give it a shot. Let's see if that works. More paper clips, got to be better, right?
I think so. And again, you're utilizing materials that you would quite commonly find in your own home. Now, again, let's think about this. Let's say you didn't have paper clips, right? So we could probably use something, maybe we could use a coin or something, right? Or even if you went outside and found a small pebble and attach that pebble maybe via a rubber band or something. But I mean, you have some chewing gum, obviously you can add some chewing gum, right, to your So, all right, so Doc said add another paper clip here. So now we've got 2 paper clips.
See what that does. That's got to be a good thing to try.
All right, so I crisscrossed them a little bit there. We're gonna stick that back in. Now by this time, Uncle Ephus is going, how in the heck did that young kid take my $100? Now if Uncle Ephus has a roll of hundreds, he can spare one. If you notice, I didn't even have to put the lid on the bottle, okay? Those 2 paper clips provided enough weight to make this packet of mustard more dense, right? So again, I think these are things that you can do in your own house with your students, but I think it's neat to put these materials in front of the students or the child and allow them to modify and change on their own. I think it's great to have an educator here that's able to decipher these things, but
I bet you can get another 100 out of Uncle Ephus if you change the water in this to salt water and ask him, could I make it float again?
Oh, well, how about that?
He's not going to believe you could make it float.
Well, I just happen to have some salt water. And if you guys out there can see, the water that's a little bit cloudy obviously has an amount of salt in it. Now, you kind of have to go home and modify what you're doing here. Now, I didn't take the paper clips off of my packet there. You'll modify this to the size of the bottle. Now, I added about 1.5 tablespoons of salt to my packet, or excuse me, to my water here. And let's see if that's enough salt to allow my Cartesian diver to float. And you know what, folks? I think, when you're doing these experiments, these are simple, little, eye-catching. Now, again, didn't even touch the packet, but it still has the 2 paper clips on it, okay? Put the lid on. If you can see, the water's a little cloudy, and that's because I added that salt. Like Doc said, making the water, this is a question out there, more or less dense than the packet, right? Squeeze, and there goes our Cartesian diver.
Wow, full circle.
Yeah.
You made it all work.
That's because of you, Doc, and I think it's wonderful to have somebody here who's able to translate that on a very simple basis. So hopefully you'll enjoy making a Cartesian diver in your own home. Now, Doc, do we have some other things that we can show the folks out there that use and utilize simple physics?